Hey guys, in this video, we're going to look at an easy trick on how to draw the shapes of orbitals for S, P, and D. For matriculation level, you only need to know how to draw these three shapes of orbitals. We're going to start with the easiest orbital first. How to draw the S orbital. The first thing you need to have is you need to draw these three axes, X, Y, and Z. Okay, you have your X, Y, and Z. You need to have this first. And then for S orbital, it's quite easy. So for S, just remember S stands for spherical. So the shapes would be spherical. You can have it like this. So this is your S orbital. So by drawing that in exams, you should be able to get 1 mark. One thing that you need to note, the size of the orbitals, even though they have the same shapes, as you can see here, they all have S shape, 1S, 2S, but 1S is smaller than 2S. Why? Because you have smaller principal quantum number for the yellow one. Here you have 1S, and right here you have 2S. So the principal quantum number will determine the size of your shapes. So when you look at 3S, 3S will be bigger than 2S, and of course 4S will be bigger than 3S. So again, you need to remember the principal quantum number will determine the shape, the size of your shapes. Now let's have a look at very simple examples here. This is quite a typical questions in exams when they want you to draw the highest energy orbital of magnesium. So you are given with the proton number right here. Okay, so that is the proton number. Very typical question. And then when you know that is 12 and this is not in ionic form, then you can say that the magnesium has 12 electrons. And then that 12 electrons, when you arrange in SPDF notation, you'll get 1s2, 2s2, 2p6, 3s2, 6, 7, 8, 9, 10, 11, 12. Okay? 1, 2, 3, 4, 10, 12. So that is 12 electrons. So the highest energy orbital, okay, so the highest energy orbital will be the outermost orbital. The one that will be further away from the nucleus, which is this. So that one will be the furthest away from nucleus. So it happens to be a s orbital. So when you draw that, 3s, okay, and then to get your full mark, you need to write 3s orbital underneath your shapes. So in exams, you'll get 1 mark for this, and then 1 mark for the label underneath. Next, we can have a look at p orbitals. For p orbitals, we have three orientation. We have px, we have py, and we have pz. Okay, remember, for p orbitals, it has three orientation. Okay, because remember, the value of p, the value is 1. So when you have p equals to 1, the value, so the m value would be -1, 0, plus 1. So this is why you have 1, 2, 3 orientation, because the value of m when p the value is 1. Okay, so the angular momentum quantum number is 1. So the m value is -1, 0 plus 1. That's why you have 1, 2, 3 orientation. So how to draw these orbitals easily? Again, you need to have the axis first, and you need to label them accordingly. So for px, you can have it along the x-axis. So you're going to put one here, lobe. Okay, so it will be in lobe shapes. So this is the shapes. Will be in dumbbell kind of shapes. Okay, so that is px along the x-axis, and then py along the y-axis. One lobe right here, and then another lobe along that side. Okay, and for PZ, you can guess that already. It will be along the z-axis right there. So that is z. Okay, so it's important for you to draw your axis first, and it will be super easy for you to draw the axis afterwards. So there you go. So these are the three orbitals of P, the three shapes. We have Px, Py, Pz. Let's have a look at a very easy example. Draw the highest energy occupied orbitals in fluorine when you have Z equals to 9. So over here, that one should be fluorine. I'm going to change that first. So fluorine has 9 electrons. Okay, fluorine has 9 electrons. So 9 electrons, you can have 5, 6, 7, 8, 9. So when you do the SPDF notation, so the highest energy occupied orbitals. Okay, so that is the highest energy 2p5 over here. You can draw that one as well, but this time we're going to focus on the p orbitals. So when you want to draw that, okay, you need to remember to write this. So this is the thing that I would like to emphasize. When you have a specific orbitals you need to draw, you need to write the specific subshell or orbitals down there. So you get 1 mark here, 1 mark there, like so. Right. Now, drawing d orbitals will require some additional skills. So we have 2 types of d orbitals, 2 ways of drawing. So number 1, we have 2 types of shapes of orbitals that will be along the axis. And 2, we have 1, 2, 3 orbitals that will be drawn in between axes. So the number 1 over here will be easier than number 2 because number 2 can be a little bit confusing, but still it is not that difficult. Now, when you want to draw those along the axis, again, you have to start by drawing the axis first, like what we have done before. We have the XYZ axis. And for those with dz square, and over here we have dx squared minus y squared, these are along the axis. Remember, those with to the power of 2 will be along the axis. If I'm going to go back slightly here, if you look there, that's how you can be told that when you see the to the power of 2 here, those d orbitals will be along the axis, and those without, like this, xy, xz, yz, will be between the axis. So that's how you're going to be able to tell yourself which one will be along the axis and which one will be in between the axis. It's quite easy. Now, for dz square, this one is quite fun to be drawn. Okay, you're gonna have along the z-axis like this. Gonna make that bigger. Okay, so this one is it's kind of like PZ, but what we have here is this ring. Okay, you have a ring. So that is how you're going to draw the dz square. You have like a donut ring surrounding your along the z-axis. And then for the dxy minus y square, it will be along the y-axis. And then you have along the x-axis. It's like a clover leaf shape. Okay, so it needs to be on the axis or along the axis. As you can see here, they are along the axis. So again, you draw the correct shapes. Red, one mark, one mark, one mark, one mark. Now, what about those in between axes? So for this one, it is advisable for you to start with these two axes first, okay? You start with this, for example, for dxy. How do you do this? Is the easiest way of doing this. So since you have in between x and y, so you're going to write x and y, okay? Then you should draw the lobes in between those axes, like this, okay? And then you can start to put the z-axis slightly. This is a bit tricky here, guys. So slightly get that. Okay, first you can see that this is in between the x and y axis. We're gonna put the z axis later. Okay. Okay, I'm gonna try to do that now. This is a bit tricky when you get to the z-axis. So let's say you're gonna make it slightly kind of like that. Let's see if I can put yellow on those. So this should be okay, something like that. So this is going to be your z-axis, okay? So you're going to do the same thing for this. You have x, z, okay, because you have x, z over here. So you'll get this, yes. You're gonna put your z-axis slightly at an angle. Sorry, this is going to be your y-axis, not z, because you have z over here already. You have your y-axis there. Then okay, so that's how it looks like. And finally, for dyz, you put y and z right there. Since you have dyz, put your lobes, one in between, and then another one in between like this. Then you're going to put your arrow. This is going to be the x-axis. Okay, x, y, z. Just going to put color or darken your lobes. Okay, so that's how you're going to draw the d orbitals for the in-between axis. Right here, we can have a look at examples from Google search. If you look at the pictures here, you can see the difference. For example, for dz square, you have the lobes and the donuts. Dx squared minus y squared along x-axis, along y-axis. Dyz, so you can have it along the yz axis, and the x-axis is going through there. You can see that the xz here, the lobes are between the xz axis and the y orbitals is going through right here. And dxy, you can see that these are between the y-axis and you have the z orbitals going outside. If you can draw 3D like this, that would be quite awesome. But if you do it 2D like this, it should be fine in exams.